Hello, and welcome to our lesson on warehousing and storage equipment. In this segment, we will continue discussing the objectives of good warehouse design and management. Storage considerations in warehouse design are crucial due to their substantial space occupation, which significantly impacts building costs. Operational storage systems play a pivotal role in product protection, integrity, stock access, correct rotation, and overall management ease. The diverse nature of materials, varying in weight, size, brittleness, hazard characteristics, and shapes, underscores the importance of adaptable storage solutions. Unit loads, like pallets, facilitate handling equipment and standard storage, while the need for different operational characteristics in storage systems arises from variations in order picking and throughput patterns. Clearances, both horizontal and vertical, ensuring safe access, as well as guidance on storage equipment usage, can be found in codes of practice published by the Storage Equipment Manufacturers Association, SEMA. The major elements affecting choosing a storage system are given below. The effective use of building volume, vertical and horizontal. The characteristics and nature of the unit loads and items held. Good access to stock. Maintenance of stock integrity and condition. Compatibility with requirements of information system. Staff personnel safety. Overall system costs. Comparing the different storage systems costs, it is not just the costs of storage equipment that must be considered. Other cost elements that can be mainly affected by the choice of system are fire protection, personnel, space, building, land, and building services, handling equipment, information management systems. Effective stock placement is vital in warehouse management. The location of stock within the warehouse impacts movement efficiency for both incoming and outgoing goods. It directly influences order selection and picking operations by determining the distance order pickers must travel to access required stock. To enhance handling and lifting, heavy products should be positioned at lower levels, closer to the picking trolley platform, while frequently accessed fast-moving stock is optimally positioned for easy retrieval at operator arm movement levels. The organization of storage locations significantly impacts the overall storage capacity of an installation. In a fixed location system, each designated place is exclusively reserved for a specific product line, necessitating sufficient capacity for the maximum stock of each item. On the other hand, a random location system allows any available space to be utilized for any item line, minimizing the installation size. Future storage capacity in random locations can be estimated based on the sum of average stock levels for all item lines, with a 10% inflation factor to accommodate variations. Regardless of the storage approach, utilization is never at 100% due to the creation of empty spaces during goods movement, affecting both fixed and random location warehouses. Typically, random placement is preferred for reverse products, which tend to take up the biggest areas in a store, while fixed locations are suitable for order-picking stock, facilitating organized storage based on factors like popularity. Efficient warehouse management requires rapid recording of each location and the ability to identify empty spaces promptly. Effective place identification systems for stock locations are crucial for the successful management of storage installations. In block stacking, pallets are directly placed on the ground and stacked on top of each other for efficient space utilization. A typical block stack has about 100 mm clearance between pallets in each row. Access to stored items is limited to the front and top pallets when removing stock. To maintain stability, loaded pallets must support the weight above, with a flat top surface for the next layer. Pallet converters can be used to transfer loads between pallets via corner posts. Rows should consist of similar items to prevent double handling, and each row must be fully emptied before refilling. Rows must not exceed 6 pallets in depth from the truck aisle to ensure safe driving. Block stacking is suitable for products with few item lines, high stock levels, and no strict first-in first-out requirement. Benefits include efficient space use, flexible block designs, and quick inventory access. Keep in mind that some warehouse space may remain unoccupied due to the need to empty rows before refilling, typically around 30% of single pallet positions. For a block storage installation with a capacity for P pallets, Plan for approximately 1429 places for 1,000 pallets, considering the 30% empty space. This is the end of this segment of our lesson. In the next segment, we will continue discussing the objectives of good warehouse design and management. This course is presented to you by South Europe College. Thank you for listening, and see you on our next segment.